Good morning, sir.
Good morning.
Good morning, sir.
How are you guys? After a long time, I'm hearing you. I don't know when I can see you. How is going?
Good morning, sir.
Morning,
Going good,
everyone.
sir. How are you, sir?
Fine. Going normal. School was reopened. It's going every day.
Yes,
Yes,
sir.
sir.
Enjoying or studying after a long time school.
Both, sir.
So for
Always-
DLA Velacheri, they are opening only on Feb 3rd.
Oh, our school also not open for grade 10. Only we are open for grade 12 as of now. Yes, we will wait for few members. Uh, So meanwhile, just go through whatever the worksheet SAR gave. Any doubts, you just hold the doubts and we'll discuss after revision of the current electricity. Okay?
Yes, sir.
How is going? Imsini,
Okay, sir.
Ovia?
Going good, sir. How about you?
Yeah, it's normal. It's busy with practicals of plus two students in my school. And next week, we are also opening for grade 10 only for practicals, not for any theory classes. So, done all the record works and everything?
So we
Yes, sir.
finished and submitted in school.
So, internal part. Then, how you done physics without readings?
So they just told to write the observation table and they didn't tell us to write any calculations.
Okay. Might be they will allow some other time to do the calculations part. Good morning, Sandhya. How are you?
Good morning, sir. I'm fine, sir.
Just we'll wait for a few minutes.
Okay, sir.
Yes, before Sir joining, instead of wasting time, just we'll have a discussion. What are the things you've done in the past 1.5 month, almost 2 months gap came for just discussion classes. All the things we are going with examinations. Am I right? Amrita, Hamsini, Ovia.
Yes, sir.
Yes, sir.
Yeah, what are the things you've done? School also classes or only examination happen in school?
Both,
Sir,
sir.
in our school, next week exams are starting, sir. Written exams, like in school.
Okay. Pre-board one. Am I right?
No, sir.
Mm.
No, sir.
Normal exams.
Normal exams, sir, for 80 marks.
Okay. Not full syllabus, correct?
50%, sir.
Almost okay. Yeah. Just anyone can kickstart the topic on current electricity. Anyone just give the what is the introduction of the current electricity? Anyone who is going to give? Sandhya, Pujita, Bhuvya, Amruta, Hamsini, anyone? Then what is the difference between static electricity and current electricity? At least that one you can explain. The basic thing. Anyone? Bhuvya, forget?
No, sir.
Open book and go through it and explain. See, I'm not asking you to explain by closing the books. Just go through the books and explain. It's not only the thing is the way how you are explaining is important for me. That's it. Unless until if you are not understood, even though by seeing the books you can't explain. Only if you know the things, then we can explain by seeing the book. Anyone? Sandhya, can you?
Sir, I'll go through and then I'll tell, sir.
Anyone can explain what makes the materials are divided into different groups like conductors, insulators. On what basis? On what basis we are saying these are the conductors and these are the materials? These are the insulator materials. And what is a
The
conductor?
conductivity, sir. Property
Yes.
of conductivity.
Okay. Then what's the inner thing? What makes it is conductors?
Sir, a material which offers low resistance to the flow of electrons in an electric circuit is known as good conductor.
So I don't know the resistance and all. Just I know the basic atomic structure of the materials. Then based on that, how you can explain conductors and insulators? Shivani, can you? The beginning I told you. Each and every material in the universe, what are the matter if you consider in the universe, it is made up of atoms. Atom is made up of molecules. Molecules is made up of atoms. Atoms is made up of atomic particles. Particles in the sense electrons, protons, neutrons, and some other particles. Correct?
Yes, sir.
So in these particles, which is the responsible? Because of this, I am saying these are the conductors. These materials will exhibit conductivity property. These materials will not exhibit conductivity property. That's the reason I am saying these are the insulators. These are the conductors. Now, at least, can you tell? There is a very small logic. It will come in chemistry also. Resistance is a different concept. Resistance is after discussing how the conductivity is happening in a materials, why conductivity is not happening. After that only we'll go to the concept of resistance. Before that, we are going to discuss the basic concept of electric charge. What is the meaning of electric charge? Bhuvya?
Sir, a charge is a physical entity which is defined as the excess or deficiency of electrons on the body.
Correct. Excess or deficiency of electrons
Electrons on the body.
in a body. If these electrons are flowing in a material from one point to another point, then we can say conduction of electricity is happening in that material. Correct?
Yes, sir.
So then what makes a few materials are conductors and insulators? A few materials, if I am seeing the like practically, if I'm using copper or iron or some other material, it will allow the electrons flow. But if I'm using wood, paper, or carbon resistors, certain things which it does
Insulin.
not flow. Yes, which makes the difference. They've gone through the atomic structure of all the materials. They found that if the materials which is having free electrons in outermost shell, the materials which is having free electrons in its outermost shell, so that will make conductors. If there is no free electrons, it will become like a insulator. So no free electrons means it does not allow to flow any electrons. It is tightly bonded within the atoms. Just a minute, guys. Sorry guys, yes, now with the help of with this information, now explain what is the conductors, what is insulator, what makes conductors, these materials are conductors, and now explain the concept of resistance, why a few materials will allow more electrons, why few materials will not allow more electrons. That's the reason high resistance material, low resistance material. Anyone now can explain? Anyone? One by one, what is electric charge, which makes conductors and insulators, and what is resistance? Bhavya, now you can try. Hamsini or Bhavya, Amrita, anyone?
Okay, sir.
Hmm.
Sir, any material that allows the flow of charge in a particular body is called a conductor. For example, copper,
Yes.
silver, etc. Any material which doesn't allow the flow of charge in a particular body is known as insulator. For example, wood.
Yes, yes, continue.
Wood, rubber.
I think Sar has Sar joined. Sir, Raghav sir?
Sir, join. No, you please continue, sir. You were asking some question, right?
No. Just I am just giving kickstart for the current electricity. Just they gone through 2 times. Just I am
Okay.
asking some few questions. You can continue, sir.
Okay, sir, I'll take it.
Guys, we'll meet again. I will take a break. Okay, sir. Thank you.
Thank you, sir. Good morning, students.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So I thought I'd take for you guys. I just want to see what is the status. Okay. So let's get started. So I hope everybody has submitted it. I received all the notifications. Okay. So let's start with this. Do you have any doubts from yesterday's the assignment which I shared? Is there anything that was tough? So because I'm seeing you guys only now. I just want to know what is the status, any difficult points, anything. Nothing. Everything is clear then. Wait. Just a minute, okay? Have some network issue. Just give me a minute, I'll solve it off. issue solved. We'll have a class. Amrita, Hamsini, Harshita, Ovia, Pujita, Sandhya, Shivani, Tillai. Okay. So I hope you're able to see my screen.
Yes,
sir.
sir.
Yes, sir.
Good. See, one thing I understand is since you have solved the assignment, the concepts are clear, right? Is there any doubt that you have? Is there anything, any topic that you want me to explain again from my perspective? I know you would have already known, but if there is anything that you want me to explain, I'll do it. Or else we will do one thing. So when I talk about this chapter, what are all the concepts that you have in it? So this electricity, what are all the concepts you are going to deal with? So we mainly concentrate on the topic called as electric current, right? So what does an electric current mean? Anybody?
The rate of flow of
Rate of
charges.
flow of charges.
Flow of charge
Okay.
to a particular
Okay. So you're saying rate, right? Rate means something with respect to time. Rate of flow of what? Charge. So charge is represented by Q. See, whenever you're learning a definition, right? Whenever you're learning a new term in physics, what is that you're supposed to know? First, you need to know its definition. Then you need to know its mathematical expression. Then its units. So what are the units of electric current? What is the unit of it? It is ampere. How did we get it? You actually got it as coulomb per second. This coulomb per second is what we call it as ampere, right? Then you would have seen a term called as potential difference. So what do you mean by potential difference? It is the amount of work done per. It is the amount of work done per unit charge. So what is the unit of it?
Volt.
How did he get? How did he get that volt?
W by Q. Work done
W
by
by Q.
Okay, work done is measured in
joules
Joules.
Joule per coulomb.
by coulomb.
joule per coulomb.
Coulomb.
Okay, joule per coulomb is what we call it as. J by C is the symbol used. This is what we call it as volt, and the symbol used is V. Right? You know what is the potential difference? It is the amount of work done to move a unit charge between two different points. Right? Then, what do we mean by a circuit? So, can you guys tell me what exactly does a circuit mean?
Continuous closed path.
See, circuit means if you use the word closed, you have a misconception. Okay, circuit is a combination of what? It is a
Various
combination.
components.
Sorry, what components?
Various components.
Okay, you're using the word various, right? What are those various components? I'll just give you an outline. It is a combination of passive and active elements. That's what elements, or you can call it as components. I'll tell you what they mean. Okay. So what do you mean by passive elements? Passive elements are the one which can take current. Active elements are the ones which can give current. So when you take a circuit, you have something like this, and you have something like this. Can I call this as a circuit?
No, sir, we don't have a key.
No, sir, we don't have a bulb. Electrics.
No. Is it so? Nothing like that, okay? This is actually a circuit. It is a very simple circuit. It is not necessary you need to have a key or a bulb, okay? See, generally the bulbs which we have at our home has resistance, right? When you solve the problem based on power, they say the resistance of this particular bulb is this much. So internally you have resistance. So this can also be called as a circuit. It's a simple circuit. So let me explain what these passive and active elements mean. So if I look at this circuit, okay, if I look at the circuit, does it have, what are all the elements it has?
It has a resistor and a power source.
Power source, that is nothing but a potential source, right? So according to what I explained as passive and active elements, can you tell me out of the resistor and potential difference, which one is the passive element?
A resistor.
Very good.
Resistor.
So resistor, because it cannot take the current on its own. What about the voltage? It's an active source. So whenever you have a combination of a passive and an active source, then that particular combination is what is called as a circuit, or we simply call it as an electrical circuit. So don't have a confusion that it always needs to have all the elements that are there in the tabular column. Not necessarily. This is also a simple circuit. Okay. Why they would have told it as a, see, if you read the textbook, why they would have told it as a electric circuit, they have used all the important components. It is not necessary that every component needs to be present in every device. Okay. Then, so you know all these things, right?
Yes.
Okay. So what is the difference between an electric cell and a battery? So what is the difference between a cell and a battery? They both
The
have.
battery is combination of cells.
Okay. When you use the word combination, is it a series combination or a parallel combination?
Connection.
You're using combination, right? When I talk about
Series,
combination,
sir.
yes,
Series,
you're right.
sir.
It is series. Okay. So how to identify that cells are in series is if the if the opposite terminal, that is the negative terminal of the first cell, is connected to the positive terminal of the second cell, then we can call it as a series combination. So observe the diagram. So a cell is nothing but a simple anode and a cathode. Whereas if those anodes and cathodes are connected together in series, then that is what we call it as a battery. Right? If suppose I have a question like this, let's say they're asking a question in this way. If suppose here it is 2 volt, the potential difference of a given cell is 2 volt. According to this diagram, okay, let's say all these 2 volt cells are connected in series and this is the battery. If I ask you what is the potential difference of this battery, what will you say? This is, you're able to understand my question? I'm repeating it again, listen. I have a cell in my hand which is of potential difference 2 volt. I'm taking all those 2 volt cells and connecting across each other like this. Okay. How many 2 volt cells did I take into combination?
3.
So what will be the potential
3.
difference of this battery? It will be 6 volt.
6 volts.
Okay, how did you get that 6? Because this 2, 2 and 2 is getting added. See, this is a very rare question that they can ask. But since these source-based questions and everything are there, I'm just trying to estimate the probability of this question being coming. Okay, now you're clear, right? So when you take the cells and connect them in series, you add all the values so that you get the net output of the battery. See, suppose. So generally what they do is, if they give something like this as 6 volt, then what is the inner meaning of it? So this is what? Is it a battery or a cell that I've drawn?
Battery.
It's a battery. So if I have to describe about this battery, can I call it as cells of 3 cells of 2 volt in combination? Right? Are you getting a different perspective towards it?
Yes, sir.
Yes.
Yes, sir.
That's good. That's good. So this is about that. Next is plug key or a switch. So this is under open condition. And when I talk about a plug key or a switch with a dot in between, then it is called as a closed condition. Sometimes what they do, they give like this also. What does this mean?
Open circuit.
Open.
Open circuit. Now I have a question. Okay. Is this a circuit or not? Is this a circuit or not?
Yes, sir.
Yes, sir.
So what kind of a circuit is this?
Open circuit.
Open
Open
circuit.
Open circuit.
Open circuit.
So what is the difference between an open circuit and a closed circuit?
There are no flow of charge in
No
an
flow
open
of
circuit
charges
cell.
in open circuit.
Okay, that's right. So that is one way of understanding, or you can say there is no continuous flow of charges. That is more important. Okay, there is no continuous flow of charge to the device. Maybe it will flow one time and it will stop. Okay, so that's what an open circuit is. Good. You people know that This is a wire joint. This we see in the problems. This is wire crossing the joining. You know what is the symbol for a bulb? Resistor you have already used. Similarly, you have a variable resistance or a rheostat. This also we keep using. Now, I have a question. Any idea about what is the principle on which a variable resistance works? Have you seen this? Have you seen a variable resistor? So I take the answer as no. Okay. If suppose I want to frame a question like this, the principle on which a variable resistor works. It works on the principle R is equal to, so how do you write the resistance in terms of resistivity, length and area?
Rho L by
Rho
A.
L by A.
Rho L by A.
That's right. So R is equal to rho L by A is what we write. So this is the principle on which a rheostat works. You can make a note of it. So all these things I'm saying are like slightly higher order thinking skills because I'm trying to estimate what they're going to ask because you have source based and assertion reason question. Okay. So make a note of it. Next is, you know what is an ammeter, right? So generally in physics, right? If you see the word meter, it is a measuring device. So what does an ammeter do?
Measure current.
Measures current.
It measures current. So am is derived from ampere. So if there is a device which is able to measure the current, then we call that device as an ammeter. Similarly, what is a voltmeter? Meter is a device which
It
is used to
measures
measure
potential.
potential resistance. Similarly, in the next chapter, you will see a device called as a galvanometer. Do you guys remember this?
Yes,
In the
sir.
case of,
Yes, sir.
so here also you have something as meter. Then what does this galvanometer do? Can someone tell me what it does?
Measures magnetic current, sir.
No. So galvanometer is actually a sensor. It doesn't measure at all. Okay, there is one exception. It doesn't measure. It only detects current. Okay, when current is flowing in the circuit, what will a galvanometer do is a galvanometer will just show a deflection. If it starts moving away from its original position, then we call it as current is flowing. Okay, are you able to understand? So there is another point I just wanted to mention. Okay, now we'll go to the other thing. You would have applied it many times. What is this Ohm's law all about?
V equal to
Relationship.
IR.
Okay, so I don't want a mathematical expression. I want a statement for it.
The electric current flowing through the conductor is directly proportional to the potential difference, provided the physical conditions do not change.
Okay, you use the word physical conditions, right? What are those physical conditions you are concerned about?
Temperature.
Is it only temperature?
Temperature, size, or shape.
Yes. Okay. Perfect answer. I got my answer. So you people are saying potential difference V is equal to IR. You told the amount of current that is flowing through a conductor is directly proportional to the amount of potential difference you apply. Okay, I understand that. So when I remove the proportionality symbol, you are going to write it as I into R. Correct? This is what you are going to write. Right? That's what I understood from what you people stated. Now I have a question. You people mentioned that physical conditions have to be constant, right? Like physical conditions when I told temperature, length, shape, and all those things. Okay. My question is, why is it so? Why do we need to have them as a constant? If they are varying, what is going to happen? Do you know the answer or not? Not sure? Listen.
Yes, sir.
Okay. Now see. When I say V is directly proportional to I, see always when a law is defined, right? Whenever the law is in physics, okay, I'm just generalizing. Wherever you study a law based on proportionality, when you remove the proportionality symbol, what do you introduce?
A constant.
Constant.
Constant. Constant of proportionality.
You call it as a constant of proportionality. So what do we mean by constant? Our basic English says constant means some parameter which does not change with respect to time. Correct? So that's what I'm able to understand. Now there are certain factors. Okay, I just want you all to make a note of it. These are all some important points. Here, what is a constant of proportionality that we are introducing?
The resistance of the conductor.
We are introducing the resistance of a conductor. Means I need to ensure the physical conditions which will affect the resistance of my conductor to be constant. It is then I am allowed to apply Ohm's law. So what does that indirectly mean? The resistance of a conductor, write it down. The resistance of a conductor increases with temperature and decreases with temperature. Please make a note of it. So underline the word conductor. Underline the statement resistance of conductor. So resistance of conductor, okay, increases with temperature and decreases with temperature. So what does that mean? If I increase the temperature of my surrounding, resistance of my conductor will also increase. If I decrease the temperature of my surrounding, it will also decrease. Means when you do the same Ohm's law experiment, let's say you're not doing it in the lab, let's say you're doing it in some AC room, then what will happen? There will be a temperature drop. Right? Are you able to understand? So suppose you do the experiment in your lab at a particular temperature. Let's say at 27 degrees you're doing it. Suppose you come to a room, an AC room, and you're doing it at 18 degrees Celsius. Then what will happen to the resistance? There will be a drop. So the value of resistance that you're actually measuring will not be accurate. That is one thing. So that is what I understand from temperature. Am I clear, students? Am I clear?
Yes,
No
sir.
confusion?
Sir.
Now, why did you people use the word length and shape? Now, I've given you the hint, you can think about it. Is resistance dependent only on temperature? What are all the other parameters that are associated? It depends on the, I wrote a formula, R is equal to rho into L by A. So what are all the other parameters it depends on? It depends on
The
the
length
length,
of the conductor and area of cross
Area.
Area of cross
area
section.
of cross section. So when you try to change the shape of the conductor, there is a high possibility that you're trying to disturb the area of cross section of it. So if either of the parameters are changing also, the resistance of the conductor will change. Are you guys able to understand why that statement is very important? So when you're
Yes, sir.
stating,
Yes,
you
sir.
need to understand. So when you write in the exam, you need to underline this statement. The physical conditions is very important. I've seen a mistake. Everybody writes V is directly proportional to I. No. Provided all these things are constant. That's what physics says. Clear? That is one thing. Next is, in general, when you talk about a conductor, okay, like I'm trying to ask in terms of problem solving perspective. So when you try to solve a problem based on conductor, okay. So what is the general shape of the conductor that we take into consideration? Conductors. So when you're solving the problem based on conductors, the general shape that a conductor is going to be a small cylinder. Okay. So have this point in your mind. Next. So this graph is important. So what does this graph state? So potential difference and current are linearly proportional to each other, provided it is a conductor. Clear, guys? So one more common mistake that I see is, see, I'm just explaining you the thumb rule, okay? Whenever you draw a graph, what is the name of this axis? What is the name of the horizontal axis?
X-axis.
X-axis.
So what is the other name for x-axis? You would have learned it like abscissa ordinate. Okay. The other name that we call it as independent axis or input values. And generally, y-axis is called as dependent axis or output values. Okay. So independent axis and dependent axis are in terms of mathematics. Input and output are in terms of physics. Now tell me one thing. We are saying V is directly proportional to I, V is equal to IR. So what are the two parameters which are related to the input and output of a circuit?
So V would be independent, sir, or input.
Input, and I would be the output. Only if you apply potential difference, you can see the current flowing through the resistor. That's the logic, right? But
Yes, sir.
here also what is going to happen, look at the graph now, this is also an exception. Are you able to understand? So as per the answer you told me, potential difference should have been on the x-axis, but not necessarily. Okay. So there is a story. If you take it the other way also, there is nothing wrong, but things will change. Okay. You have to go with the textbook thing. So most of them make that mistake also. They take potential difference on the x-axis and current on y-axis. No. With respect to Ohm's law, no. Why it is so, you'll understand later. In your 12th standard, you'll understand it. Don't worry about it. Okay. I hope that point is registered in your mind. So I have already told you what are all the factors on which the resistance of a conductor depends on. So R is equal to rho L by A. If you read here, it depends on temperature also. That is why if you see the question, electrical resistivity of some substances, they didn't stop with it. What is the next term that they used in the textbook? At 20 degrees Celsius. That is a very important thing. Means if you start varying the temperature, what will happen to the resistivity or resistance? They will start changing. Okay. So I hope this point is also clear. Similarly, here it is mentioned you need not memorize these values. You can use these values for solving numerical problems. So you need not memorize it at all. Don't worry about it. Now we have another question. So I'm using the word R is equal to rho into L by A repeatedly. I know what is R, resistance, L is length, A is area of cross section. Then what does this resistivity actually mean? So what do we mean by resistivity? What is the difference between resistance and resistivity?
So resistivity is the resistance of a circuit or a conductor of length and its area of cross section.
Okay, so you're trying to define it like this. I'm able to understand where you got the definition. You wrote R is equal to rho into A divided by L. You're trying to define from here, right? Is this what you're trying to do?
So resistance could also be defined as a property of a conductor which opposes the flow of electric current.
Okay.
Resistivity is defined as the resistance offered by a material, sir.
Okay. When you use the word resistance, again the property is getting covered in it. Okay. Anyway, see, nobody is going to ask the definition. I just want to understand how much clarity you have. Okay, that's fine. So generally, what we can do is, you told, right, resistivity is the resistance, right? So when will mathematically rho be equal to R? If I have rho is equal to R into A divided by L, I want rho to be equal to R. What should I do to A and L for that thing to happen?
Area of cross section and length must be equal, sir.
They can either be equal or A can be 1 and L can be 1. That also makes sense. Because
Yes,
in physics, 1 means unit. Okay. So I can say, look at the way I'm going to define. The rho is equal to R, no? So resistivity is equal to the resistance of the conductor, where the conductor's length is 1 unit and area of cross section is also 1 unit. That is the mathematical definition. If you understand it, it is more than sufficient. You need not think much beyond that. If you understand it, that's more than sufficient. I hope you are clear with it, right? So I'm trying to define it mathematically. The resistivity is equal to the resistance of the conductor when the area of cross section and the length are how many units? Exactly 1 unit. If you substitute them, you're going to get it. Now I have another question. Let's say I'm giving you a copper wire. Okay, this is a practical basis. Let's say I'm giving you a copper wire in the lab, and what you're doing is you're trying to expand the copper wire. Okay, so copper wire is a conductor. So a conductor has two properties associated with it: resistivity and resistance. Now listen to my question again. You're trying to increase the length of this copper wire. Will its resistivity change or not?
Yes, sir.
Listen to my question. Will the resistivity of the conductor change? I'm using the copper wire. You're increasing the length of the wire. Will the resistivity change?
So there won't be any change in the resistivity if we increase the length.
Okay, if you decrease the length,
There won't be any change in resistivity, so it doesn't depend on the change in length.
it doesn't depend on the. You're perfect. That's a perfect answer. It doesn't depend on the length or area, but what does it depend on?
Thickness of the conductor.
Nothing like that. Resistivity, please make a note, then you have a confusion at this point also. So I told you, what are the factors? See, listen to my question carefully, okay? What are the factors on which the resistance of a conductor depends on? Length, area, and temperature. So I hope these 3 points are clear. Factors on which what depends on? Resistance, that is R. Now write down the heading as factors on which resistivity of the conductor depends on. Factors on which the resistivity of the conductor depends on. What are they? It depends only on the nature of the material. Okay, it depends only on the nature of the material and temperature of the surroundings. Or I can say temperature of the material also. So what are the 2 points? Resistivity depends only on the nature of the material and temperature of the material. So it is independent of what? It is independent of the physical conditions like length and area of cross section. Okay. Now, why I ask this question is, since you people have assertion reason, now I'll give you a question. Okay. You would tell assertion. Resistivity of copper is, let's say, X units. Okay, whatever it is from the table or they're going to give. The reason is, okay. Resistivity of copper is X unit. Its resistivity increases with temperature. So which one is right? Assertion is right, reason is right, and reason is the right explanation. You know the options, right? I need not tell you. A, B, C, D. So which option is right?
Both are correct, but
Both are
reason is not
correct.
the correct explanation.
But
say.
it has no relevance.
Assertion is not the right
Yes.
explanation.
Option B, sir.
Reason is not the right
Reason
explanation.
is not the correct
Reason
explanation.
is not the
say.
right
Reason not the
explanation of
correct.
the assertion.
Okay. Now I will change it like this. Its resistivity decreases with increase in temperature. Okay. Resistivity of copper is something, okay? Its resistivity decreases with increase in temperature.
Sir, both A and R are correct, but not correct.
R is not the correct explanation of A, sir.
So small correction. Assertion is correct, reason is wrong. Why is the reason wrong?
It
The
increases.
resistivity is directly proportional to the temperature.
It is directly proportional to temperature. Means I'm talking about copper. Copper is a conductor. So what did the point I'm trying to stress upon again, please make a note of it. With respect to a conductor, resistivity increases with increase in temperature, decreases with decrease in temperature. But what did I state? Its resistivity decreases with increase in temperature. Am I not wrong? So assertion is right, reason is wrong, obviously. So you're able to understand? So from the same concept that you know, they can twist and ask in any of the manners. This is how you need to ask questions and study. So I hope you made a note of all those points. Suppose this is another important problem that I keep seeing. Example 12.6. Suppose there is a wire of a given material. So every word is important in a question. Okay, what do they mean by given material? A wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of an other wire of the same material having length L by 2 and area of cross section 2A? Okay. So I am concerned about two words. What do they mean by given material? What do they mean by another wire of the same material? By giving those two keywords, what are they indirectly trying to tell us?
So both are of the same material, sir.
Means what will be constant?
Resistivity.
That is what they're indirectly trying to say. Are you able to understand? So
Yes,
that's
sir.
the logic we discussed. Yeah. Now, so how you're going to solve this problem is, if I take the case 1 as R1, so resistivity of the first case is rho into L divided by A. R2 will be how much? It is made of the same material. So rho into L by 2 divided by 2A. So what will be the answer? You can divide both, you are going to get the answer. Right. Now I will modify this question and ask, I want to see how much you people know. Just a minute. Now see, let's say resistance of given material is R. Find new resistance when its length is half. So resistance of a given material, that word is important, okay? By now you should have understood. Resistance of a given material means indirectly they mean resistivity is constant in that problem. So resistance of a given material is R. Find new resistance when its length is half. Anybody who can tell me? So case 1, if I say R1 is equal to rho into L by A, that is the original resistance, correct? Now what will R dash be? Since it is given material rho into, what should I write the new length as?
L by 2
By?
A.
Okay. So answer, R dash is equal to R dash divided by R is equal to, what will you get? Rho into L by 2 divided by A divided by rho into L by A. Cancel, A and A will get cancelled, half. R dash is equal to R by 2, right? I hope you understood.
Yes, sir.
Yes,
Yes,
sir.
sir.
But it's wrong. Why? This is also another type of question they can ask. I've seen. But it's wrong. What you people told is wrong. Why?
Sir, I'm getting it as doubled, sir.
Double means you're saying 2R. Are you trying to say the answer is 2R?
Yes, sir.
No, that's not. That is also wrong. Resistance will definitely decrease. One thing is clear, length is decreased because resistance is directly proportional to length. Resistance has to decrease. If the original value is R, the final value also should be less than R. That's what the logic says. R is equal to rho L by A. But can someone tell me what is the mistake I did here?
They didn't mention it's the same material.
No, that's right. See, given material, Abdinal, I told no. Given material, if they use the word given material, resistivity is constant. If they use the word given material, resistivity is constant. That's nothing to do with resistivity. I've done a mistake in some physical condition. When the length is changed, do you think the area will still be the same? Answer is no. Because, see, wait, I will switch on my video. I will ask you some questions. Okay? You people tell me. Just need a stand. Just give me a minute. Are you guys able to see?
Yes, sir.
Suppose if I take this as the conductor, you have connected this across a positive terminal, this across a negative terminal, okay? So this conductor's length, I'm calling it as L, means what? The distance between these 2 points is L. Then what about the area of cross section? This is what the area of cross section is, right? Its area of cross section, if I take it as A. Now, if I try to, listen to my question carefully, if I try to elongate it, if I try to pull this, imagine this like a rubber band, okay? If I try to pull this to double its length, will this thickness still remain the same?
No, sir, it will decrease.
It will decrease, sir.
You would have seen, right? A rubber band will become thin, right? But
Yes,
my
sir.
question, what is remaining constant there? Of course, resistivity, that point is okay. It is actually the volume of this material that is constant. Am I right? It is the
Yes, sir.
volume is constant. So what is the volume of this particular material in terms of area of cross section and length? See, area of cross section is A, length is L. So what is the volume in terms of area of cross section and length?
Length into area of cross section.
That's it. It's simple. That's what surface areas and volumes is telling us. Because the area is pi r square into L is, that's the volume of the cylinder. Right? Now, are you guys convinced with the factor that the volume remains constant?
Yes, sir.
Yes, sir.
Now let me show you what exactly happens. So when the volume is going to be constant, now listen to this carefully, okay? Initial condition is something like this. Its length is L and the area of cross section is A. The final thing will be half of it. So when you bring it close, what will happen? Its volume, its area will increase. If I call the new area as A dash, then what is conserved? Volume is conserved, correct? So what is the initial volume? A into L should be equal to A dash into L by 2. So what will be the value of A dash? It will be 2 times A. So this is a very, very important point to be noted, guys. Are you able to understand? So what I'm trying to say is, next time onwards, you need not sit and show all these definitions. I explained it for you. Next time onwards, if you see a question like this, if length and area are inversely proportional to each other, that's what I want you to have in mind. Means length is half, what will happen to area? It will get doubled. Length is doubled, area will get. Length is doubled means what will happen to the area? It will get
2, sir.
It will become A by 2. Now tell me the problem. Okay? In original resistance is rho into L by A. Now correct your mistake. R dash is equal to rho. Given material means rho is constant. Length has become half. So what will happen to the area?
2A, sir.
It will be 2A. So what is the answer? Rho into L divided by 4A. So rho L by 4A is, rho L by A is nothing but R. So it is R by 4. Because rho L by A is R, correct? So rho L by 4A will be R by 4. So resistance is decreasing, but what was the mistake? You got it as R by 2, but the actual answer is R by 4. Convinced, guys?
Yes, sir.
Yes,
Okay,
sir.
please make a note of these points. You can get these kind of questions. Shall I move on to the next one?
Yes, sir.
Okay. So this is again an important point. When I talk about resistance of system of resistors, I can talk about what combinations. So when I talk about combination of resistors, okay, when we talk about combination of resistors, what are the two combinations that we know?
Series parallel.
Series and parallel.
Series, parallel, and sometimes it can be
Both
mixed also.
together.
It is mixed combination. Okay. Now the question is, how do you define a series combination of resistors? So how do we define the series combination of resistors? So in series, what remains constant across the resistors?
Current.
Potential difference.
No. Current. It is electric current that is constant. Means if the current remains constant across all the resistors in the circuit, we call it as series. Then what about parallel?
Potential difference.
Potential.
Yes. So it is a potential difference that is constant, in which we cannot generalize something. Okay. So if suppose I have resistors like this connected across a potential source R1, R2, R3. Okay. If I draw the equivalent circuit of it, I call the equivalent resistances R equivalent. First, I want to know what is the value of R equivalent in the case of series. R1 plus R2 plus R3. Known fact. Now I have a question. What do you actually mean by equivalent resistance?
Total resistance.
Okay, if you call it as total resistance, why in parallel you are not calling it as total resistance? If total means sum, total means sum. So sum of the individual resistance R1 plus R2 plus R3. Then in parallel also they should have been R1 plus R2 plus R3. If it is total resistance, there it is not the same. Why? Okay, I'll just explain it. Listen to it. Okay. R equivalent or equivalent means in the left hand side, okay, in the left hand circuit, how many resistors did we use?
3.
3. In the right hand side, we have only 1. So here in this circuit, 3 resistors are doing some work, whereas in the right side circuit, there is only 1 resistor doing the work. Means if you are able to replace all the resistors in a given circuit with one particular resistance, which can do the work done by all those resistors, then that resistor is what is called as an equivalent. Okay. So in the terms you understand, instead of taking a resistor, if I take a bulb, I told you already, right? A bulb also has resistance with it. Students, I think there was some network issue. Am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
So where did the issue start actually? Just a minute. So where did my voice start breaking?
When you were saying bulbs, sir, the second diagram.
Okay, that part you could hear, right then. So now you understood what is an equivalent bulb, right? That is one bulb. So these three bulbs, let's say they are in your room, and each bulb will give you some amount of brightness. So instead of using three different bulbs to produce some brightness, if you can replace with one bulb that gives you the same amount of brightness, then that is what we call it as an equivalent bulb. Am I clear with this point? In a similar context only, if you instead of using multiple resistors in a circuit, if you replace them with one particular resistance, that resistance is what is called as an equivalent resistance. Okay. Similarly, when you talk about parallel combination, R1, R2, R3. Okay. In parallel combination, what remains constant? It is the potential difference that is going to be constant. So what is the equivalent resistance formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Right. So that's what is an equivalent resistance. Now, I have another question. If I talk about an ammeter and voltmeter, there is an often asked question. How is an ammeter connected across the circuit? Series or parallel? Reason?
In parallel, the current gets divided.
Parallel current gets divided because when you use the word series, current remains the same. So suppose they give an assertion like this: ammeter is always connected in series across a circuit. Reason is current remains the same. What is the answer? Assertion is ammeter is always connected in series, and the reason is in series combination current remains the same. So assertion is right or wrong?
Correct, sir.
Reason? Correct. So assertion is reason is the right explanation for assertion. Similarly, voltmeter is always connected in parallel because in parallel combination the potential difference is constant. Okay. Now, so you guys know how to find the equivalent resistance, right? Now I'll give you a small problem. I want you to tell me. Two, three, 4, 5. All these are ohms. I want you to find the current in 4 ohm resistor. Okay. This is a combination of everything. Now we need to raise certain questions. Is this a series circuit, parallel circuit, or a mixed circuit? It's a mixed circuit. So what is my question saying? I need to find the current in the 4 ohm resistor. How do I do that? So you can apply, remember, you can apply V is equal to IR formula. For example, I'll apply and show. See, let's say this is a 4-volt battery. Okay. Let me take even numbers. This is 2, length is P6. Okay, this is a 4-volt battery. Can I write the current through this particular device? Current through the first 2 ohm resistor is 4 divided by 2. Can I directly write it like this? I is equal to V by R. Since V is 4 divided by 2, can I say current through the 2 ohm resistor is 2 ampere? Can I say it like that? Guys, are you able to understand my question? I have a 4-volt potential difference source. I have a resistance of 2 ohm. If I ask you what is the current through the 2 ohm resistor, I'm going to say 4 by 2. Am I right or wrong? Are you able to hear me? What happened? Are you able to understand what I'm asking? So I'm saying the current through the first 2 ohm resistor is 2 ampere, correct? Is it right?
Yes, sir.
Again, the answer is no. Why? Have you ever solved this kind of a problem? Tell me that in the first place. Have you ever solved a mixed circuit? Suppose this is an example of a mixed circuit. This is also an example of a mixed circuit. You would have solved it, right?
Yes, sir.
Okay. Now tell me. Okay. Tell me the method which you know. How do you proceed? So
Sir,
let me
we
name
should
it.
find the equivalent resistance of the circuit.
Yeah. How do I find it?
So first we have to solve everything in parallel.
Okay.
And then we have to bring it to the series combination and then add them up, sir.
Okay. Tell me. So the resistance across AB is 2 ohm. What is the resistance across BC?
1 by 2 plus 1 by 4, sir, which is 3 by
1 by 2 plus 1 by 4 is 1 by RBC. For RBC, 1
so
by
4 by
RBC,
3, sir.
1 by 2 plus 1 by 4. Let me check. 6 by 8. It is 3 by 4. Yeah. RBC is 4 divided by 3. That's right. 4 divided by 3 ohm. And the resistance across CD is how much? 6 ohm.
6 ohm, sir.
So what will be the new circuit?
4 by 3 plus 2 plus 6, sir.
So 2 plus 4 by 3 plus 6. This is 4 volt. Okay. Why did I write 2 plus 4 by 3 plus 6? Because if you replace these two, it will become a 4 by 3 ohm resistor. So 2 ohm, 4 by 3 ohm and 6 ohm are in series. So 8 plus 4 by 3, how much is that? 24. 28 by 3 ohm is the equivalent resistance. So what will be the current through the circuit? So current through the circuit is V by R.
28 by 3.
No, 4 divided by 28 by 3. It is 12 by 28. How much is it? 6 by, or I can make it as 3 by 7. V is equal to IR, no, I is equal to V by R. So it is total of 3 by 7 ampere that is flowing through this circuit. Are you clear with this?
Yes, sir.
Okay. Now what was my question? I want you to find the current in the 4 ohm resistor. Okay. Please make a note of this thumb rule. You can apply V is equal to IR. You can apply V is equal to IR, which is Ohm's law, provided there is only one potential source and one resistor. So V is equal to IR can be applied only if you have one potential source and one resistor. So to answer that precisely, if I do I is equal to V by R and write it as 2 ampere like how I told here across this 2 ohm resistor, that is wrong. Because this circuit had how many elements? It had 1, 2, 3, 4 resistors. But I applied Ohm's law individually for one resistor. Don't do that mistake. So how do I find the resistance across the 4 ohm?
So the resistance will become 4 ohms, sir.
Sorry, not the resistance, the current across 4 ohm. Okay, listen, what I'm going to do is 2 ohm Anybody got an idea? So this is 2 ohm, this is 4 ohm, this is 6 ohm. Okay. Now what is the total current supplied by this battery according to equivalent resistance? So now the reason why we found the equivalent resistance is because we wanted to find what is the total current through the circuit. That was how much? 3 by 7 ampere.
3 by 7 ampere.
So 3 by 7 ampere is supplied by whom? Supplied by the battery of potential difference 4 volt. And this 3 by 7 is flowing across what all resistors?
2 ohm resistor and
Yes.
the parallel combination 2 ohm and 4 ohm and 6 ohm resistor.
Perfect. This is A, B, C, D. Okay. Now, current through AB is how much? It is 2 ohm. Clear. Current through CD is how much? That is, sorry.
4 by
Current
3.
through AB, that is 2 ohm, is 3 by 7 ampere. Current through CD is what? It's a 6 ohm resistor. Is how much? That is also 3 by 7 ampere. How did I say it is 3 by 7 ampere? Because 2 ohm and 6 ohm are in series. I hope that point is clear. Right?
Yes, sir.
Now, tell me, what is the potential drop across AB? Potential drop across AB is equal to current across AB into resistance of AB. So, what is the current across AB?
3 by 7.
Into what is the resistance across AB?
2.
2. That is 6 by 7 volt. Similarly, what will be the current through CD?
3 by
Current,
7 into 6.
perfect. 3 by 7 into 6. Because I am applying V is equal to IR. How much is that? 18 by 7 volt. What is the total potential difference across the circuit? 4 volt. So, potential across AB plus potential across BC plus potential across CD, can I call it as 4 volt?
Yes, sir.
Because that's how we derive series resistance. So potential across AB is 6 by 7.
6 by
Potential
7.
18 by 6 by 7 plus potential across BC plus potential across CD, that is 18 by 7 is how much? 4 volt. So what is the potential across BC? 4 minus 6 by 7 minus 18 by 7. So 4 minus 24 by 7, that is again 4 by 7 volt. Did you understand what I did?
Yes,
So,
sir.
the resistance across BC is how much? 4 by 7 volt, means from this 4 volt, only 4 by 7 volt is getting supplied across 2. Now, how is this 2 ohm resistor and 4 ohm resistor connected?
Parallel.
They are in parallel. So, what will be common between them?
Potential difference.
Potential difference.
So, can I write it like this? Current across 4 ohm resistor is equal to potential difference across BC divided by resistance of 4 ohm. So what is the potential difference across BC? 4 by 7
4 by 7.
divided by 4. What will be the answer? 1 by 7 ampere. Means from a total current of 3 by 7 ampere that is flowing through the whole circuit, how much is going to the 4 ohm resistor? It is 1 by 7 ampere. So, how much remaining will actually go through the 2 ohm resistor which is present in parallel with 4 ohm?
2 by 7.
2 by 7.
Did you guys understand?
Yes, sir.
I know it is a slightly tough problem, but I wanted you to understand the logic. So now are you guys clear with how to deal with series and parallel and mixed combinations?
Yes, sir.
Okay, that's good. So can I give a similar problem? Will you do it? Similar problem and 3 minutes time.
Okay,
Will
sir.
you try? Yeah, we'll do it. So did you copy all these things? Anyone wants to copy this? Okay. Let's do it. Two, 6, 3. Volt back. Current through 2 ohm resistor. Yeah. Anybody with the answer?
1 minute, sir.
Okay, do it. Do it.
Sir, I'm getting 2 by 9, sir.
2 by 9. Anyone else with the same answer? I don't know what is the answer. I randomly created the question. 2 by 9 is what you got, right? Anyone else? Okay, let's try this out. So, resistance across AC is equal to resistance across AB plus resistance across BC. So, for resistance across AB, 1 by RAB should be equal to how much? 1 by 2 plus 1 by 6. How much is this?
2 by 3, sir.
Okay, first it is going to be 8 divided by 12. So RAB will be equal to 4 divided, it's 3 by 4, right? Sorry, 3 by 2.
So, simplification, we get 2 by 3 and R is 3 by 2.
2 by 3. LCM is 12. If I take it somehow 8 by, so RAB will be 12 by 8. No? 12, it goes with 4. So is it not 3 by 2?
Yes, sir. We have to reciprocal it, sir. I got 2 by 3. I reciprocaled it, so I got.
Okay, you told that one as 2 by 3. Okay. So resistor RAB is 3 by 2, but in parallel, yeah, 2 by 2 and 6 are big. So resistance across AC will be 3 by 2 plus how much? Plus 3. That is 4.5, which is 9 by 2 ohm. I hope this point is clear. 9 by 2 ohm.
Yes, sir.
So what will be the equivalent circuit? It is like a 9 by 2 ohm resistor is connected across how many volts battery?
6 volts.
Across a 6 volt battery, which implies I will be equal to 6 divided by 9 by 2. So it will go 2 times, 3 times. It is 4 by 3 ampere. Is this what you got? So out of 4 by 3 ampere, here it is 4 by 3 ampere that is going to flow. Right? So
Yes,
what is the
sir.
potential? So potential difference across AB plus potential difference across BC is 6 volt. So potential difference across AB is what we need to find. What is the potential difference across BC? IBC into RBC is 6. So VAB plus, what is the potential difference across BC, guys?
Sir, I made a mistake, sir. Instead of multiplying 2 into 2 by 3, I just put 2 by 3, sir. The value went
Okay.
wrong.
That's fine, but you are able to understand the concept, right?
Yes, sir.
So IBC is 3, RBC is how much? 4 by 3 is 6. It will be, so potential difference across AB will be 2 volt. Is everyone clear with this 2 volt? So there will be a potential difference of 2 volt acting here. Out of the 2 volt, what did they ask? They asked the current through the 2 ohm resistor. So what will be the answer? I is equal to V by R. How much is the answer? It is 1 ampere. So here it is 1 ampere and here it will be 1 by 3 ampere. Guys, everyone, are you clear with this concept?
Yes, sir.
Good?
Yes,
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 sir.
sir.
That's right. That's good. Okay, you can try out some more problems of this sort. So for example, you have a question here. See, you can take the same question. What they asked is, they asked the total resistance in the circuit, the total current that is flowing in the circuit. You can take it as a task to find out what is a current through each resistor. That will be a slightly challenging task. You can do that and send it to me. I'll verify. Okay. So the only concept that is left out is heating effect of electric current. I will try to accommodate some other day to complete it. Okay. So I hope the concepts are clear in today's class.
Yes, sir.
Yes, sir.
Yes,
So if
sir.
there is any doubt, okay, I just want to make an announcement. Listen. See, 97910. Please make a note of these numbers. No, there are two numbers. See, this 97910 is what I use for announcements. Okay, this is mainly used only for announcements and other admin works. So going forward, you don't message your doubt in this number. Rather, you can message me in this number. Please make a note of this. This is the student support number. Okay. So whatever doubts you have going forward, you message in this. But when you're messaging me for the first time alone, ensure you send me your name because I don't have everybody's contact saved. So this will be the number in which I'll be available, 6369-210-899. So any doubt you have, you can message me. So it, not only with respect to physics, you can send it across for all the subject. So physics and maths, I can respond back also, not an issue. Chemistry and biology, once you send me the doubt, I will forward it to the teachers. I'll get your doubts clarified and send you back. The reply time will be within 24 hours because I'll be in class or other things. I might not be able to respond soon. So within 24 hours, I will respond. Students, am I clear with this? Please make
Yes,
a note
sir.
of it.
Yes,
Yes,
sir.
sir.
So going forward, don't message on this number at all. And in the group also ensure you don't ask any questions because if there are any important messages, they are lost. Okay, if there is something you need clarification for, if there is some mistake in the question, you have any kind of clarification, reach out only on this number, the second number, 6369210899. Okay, so that's it from my side for today. I'll see you guys in the next class and we'll solve heating effect of current. And if you have any other questions, let's say your school exams, whichever question you had a doubt of, or you want me to give something else also, you can approach me. I'll help you out. Okay.
Okay, sir.
So I'll see you all in the next class. Okay. You can leave, students.
Thank you, sir.
Thank you, sir.
Thank you.